odd and even functions. Does this ring a bell to anyone? Have you had anything like this before? Just checking. I'm not saying I've taught you before. I haven't actually. We're going to see the behavior of two different functions. You've just done quadratic, so it's easy to play with graph of x squared. Now, let's consider the graphs of x squared. Let me get it right. Y is equal to x squared and y is equal to x cubed. Let's consider these two graphs. Do you have a computer with you? Even though we haven't done x cubed, can you sketch on your decimals and tell me what it looks like? I'm waiting for us to do transformation of shapes before I teach you cubic and quartic functions. All right? So for x squared, it's going to look like, what we know, right? In fact, this could be kx squared, and this could be kx cubed. It doesn't matter. Okay? Consider the graph of, do we leave it as x squared or put a number? What do you guys think?
Just leave x squared.
Let's just leave it like that, so we don't complicate life for ourselves. All right, so the graph of x squared is going to go like this, right?
Yes.
And what do you notice about the shape from your sketch?
Of x cubed.
For x squared?
What? It touches
The touches at
basically
y at 0.
At 0, 0.
Okay, and what can you say about this axis?
It is the y-axis.
Obviously.
Yeah.
What can you say about the axis? I will not ask you that.
Axis of symmetry.
It's the axis of symmetry. So it's the same, right?
Sure.
So in that case, check this out, everyone. If this is 3, maybe I'll use, sorry, I'm OCD, I know. If this is positive 3, what do we get?
Oh, this is positive. Sorry.
You don't have to look at the picture, Alex. That's what would be on the board.
9.
This will be what?
9.
9. But there's a mirror
Yes.
as a result of this line of symmetry.
Yes.
The mirror of this will be where?
Negative 3.
Negative 3. And we expected to get the same.
9.
And this works for all values you pick here and here.
Yeah.
The positive and the negative gives you the same thing.
Yeah.
Isn't it?
Yeah.
A function that behaves like this. So you can see clearly that, oh, f of minus 3 is actually the same as f of 3. If I pick f of minus 4, will I get f of 4 back?
Yes. Yes.
If I pick f of minus k, will I get f of k back?
Yes. Yes.
Any function that behaves like this is an even function. The negative sign is absorbed.
Yeah.
And when you sketch such a function, it is always symmetric about the y-axis. Put on your decimals app, x to the power 4 plus x squared. Let's see if we can see this behavior again. X to the power 4 plus x squared. Do you get the same symmetry?
Yes. Yeah.
Okay? Put any coefficient you wish. Put any coefficient, plus or minus, before this and before, change it. Put any coefficient you want for the power 4 and for the power 2. Put any coefficient, make sure you have positive, negative. Play with the parity. Do you still get the same symmetry?
Yes.
About the y-axis? Okay? You get the same symmetry?
Yes.
This is an even function.
Oh.
All right? But let's test for odd. You must have done the sketch of the x cube, right? Did you get something like this? It's going to pass through y, right?
Yeah.
Then it's going to go this way, then it's going to come that way.
Yeah.
Okay. That's like one of the trig. Which trig behaves like that? Anybody know?
Oh, the tangent.
Tangents. Alex is like, yeah, don't say it, I know it. Huh?
I just call it 10.
Yeah.
Was it?
Yeah.
Something like that.
Oh. Are they connected?
No, they're not.
No.
Okay?
There's a large one.
So this behaves like this. Now, let's check this again, just like the other one. Of course, with your maybe 2, you expected to get what? Really? You expected to get what?
Oh,
8. Okay? If you check for -2, what do you get?
Negative 8.
Maybe I sketch it again.
It's okay.
But at least you understand. I'm just being OCD.
No, I think it's worse.
It's worse.
It's not as consistent.
Anyway, just manage that. You get your -8. Now, tell me what you notice, apart from the fact that, what is your comment first, before I say mine?
I think.
Yeah.
Oh, it
Never
rotates.
lie.
I like that.
It rotates 180.
It doesn't rotate, but what you want to say is what? It has a rotational symmetry.
Oh,
About,
0, 0.
use a better word.
Origin.
Origin. It has a rotational symmetry about the origin. And what can you say about f of -k and f of k?
They are the same.
Listen, f of -k is equal to
Negative f.
negative f of k. You see, you've just given me the definition of an odd function.
Oh, thank you. Oh, yeah.
So the difference is that for even function, the negative is absorbed. For odd function, the negative escaped. Like, okay, dude, I don't want to be part of this. I'm getting out. That's an odd. It's like, oh, come on, you're so odd. You gotta behave like everybody else. If you cannot, just get out. It's like the odd one out, right?
The odd number.
But does that make sense? Can you put different coefficients? In fact, try x to the power 5 plus x cubed plus x and play with their coefficients. Tell me what you notice.
Wiggly. Wiggly. Yeah.
No time for play, please. Can you play with what I said?
It's still.
I wrote a trinomial on the board. You're not listening. Come on, stop being playful in my class.
It's closer to the center.
Do we have the same rotational symmetry? I need you to observe that.
Yes.
For different coefficient that you tried,
Yes.
it behaved the same way. It has a rotational symmetry about the origin. Yes?
Yes.
Yes.
That is the behavior of an odd function. So even if I do not give you the definition of the function, I give you a picture. This is how you know, oh, this function must be even. Oh, this function must be odd. So again, odd function has a rotational symmetry about the origin,
Yes.
while even function, yes, somebody fill in the gap.
Has a rotation. No, wait, no. Has a line of symmetry.
Or you can call it axis of
Axis of symmetry.
about
About
The
origin.
No.
the y-axis. Or you can say the axis of symmetry is the y-axis.
Oh, yeah.
Does that make sense?
Okay.
Now, let's write a formal note. Now that we have explained the concept. Of course, you can write this.
So Daniel,
Yes.
even function only work if the biggest power is even, right?
No. The answer to that question is no. But just wait and see what I'm going to write.
Okay.
This rotational symmetry is of what order? Of 12 is not important, I'm just asking.
180 degrees. No, one.
Two.
One. I'm confused.
The first one
And then
is when this point comes down, the second is when it goes back to the original.
Oh!
Oh. Are you confused anymore?
Remember, you know what
Yeah,
order?
Order of rotational symmetry.
I'm just confused.
No, square has four, because it can rotate 4 times, and it's exactly the same. A triangle has 3, and that shape has 2.
anything.
Oh, I just wrote something wrong here. Minus f of x, please. So this is the formal definition to answer your question. All you have to do is check, and not when the highest power is anything, because the highest power might be, and it is neither odd nor even.
Okay.
So quickly, Look at this. Let's look at the board. Is this function odd or even? Don't answer yes or no. Just start by checking f of minus x. Okay, so your solution should look like this. F of minus x means 3 minus x squared minus 1.
Oh,
Which is 3x squared minus 1. Which gives you back what? F of x.
so it's even.
This implies that f of x is what? Is on what?
Even function.
That's all. Again, g of minus x, look at the board. Right?
Yeah.
Which gives you that. You agree?
Yeah.
Yeah.
Because this is going to be negative,
Yeah.
and this is positive.
Oh, yeah. Negative.
Right?
Yes.
If you want me to show this first, I'm happy to. Because the minus cube is minus. X cube is x cube. Okay? And this is what?
Negative.
So that's negative, which implies that g of x is an odd function. Okay? If you cannot get this, you say, oh, it is neither odd nor even. Because it doesn't have to be odd or even. Some functions can be neither of the two. Alright? Alright, so let's go to some more interesting stuff. I hope it's not part of the exercise. Suppose the sum of Elson, could you check if we are capturing this part? Okay.
Barely, but now we are completely seeing it.
Oh, but we were capturing this part before.
Both sides.
Obviously, what I'm doing.
There's no general form at the end there. And next to
Okay.
summation.
We have 12 minutes. After this last 3 examples, do you have a question, Yanko?
No. I'm just thinking of question 3.
Okay, yeah, we're going to do it together. Please pay attention. It says, prove that the sum of 2 odd functions is always an odd function. So after this, I'm going to ask you to prove or determine. Because when I say prove that, I'm already telling you the answer should be an odd function. Sum of 2 odd, yeah. So I may ask you to prove the product. Is it odd or even? You check yourself. I'm not even going to give you like a guide, right? You check yourself. Okay? What about the quotient? Can be checked too. The composite. That's a technical question I want you to try before tomorrow. I'm almost done with the worksheet. I'll leave some space, please make sure you try them before you come tomorrow, okay? If you don't get it, we can do the composite together in class. That might be challenging to some of you, if applicable, of course, okay? Now, to prove that the sum of 2 odd functions is an odd function, what do you think I should do first?
Find a general form for an odd function.
Not really.
Let the 2 odd functions be like I wrote hx and kx.
Okay, I'm just going to use f and g.
Okay.
All right, so let the 2 odd functions be f of x and g of x. That's your beginning. I need focus, please. Let the functions, okay, let the odd functions, or let f of x and g of x be odd functions, something like that.
Yeah.
Let the functions be, I need focus, okay, be f of x and g of x. We want to prove that their sum is odd. The sum of f and g looks like this. It looks like f of x plus g of x, right? We want to prove that this sum is odd. Anytime you want to prove odd or even, what do you start with?
You put x equals negative.
You change x to negative x. So you are going to start with f of negative x plus g of negative x and see if you can get negative of this back. Am I making sense? Yanko, are you lost?
Yeah, can.
Okay. Let's say this is our h now.
Okay.
This summation is h. To prove that h is odd, you want to start with h of negative x.
Okay.
And at the end, get the opposite of h of x in terms of sign. So h of negative x means change the something here. Understand? You can even introduce h if you want. Okay? Their sum, maybe we have sum, let their sum. Let this be the odd function. Let h of x be the sum f of x plus g of x. If that makes it easier. Okay? So you are actually focusing on h. You want to show that h is odd.
Okay.
To show that h is odd, you start with h of minus x. Alright? H of minus x will be f of minus x plus g of minus x.
Oh, it's not so hard.
Alright? Right?
Yes.
What do we know about f of minus x?
It
Is equal to f.
It is
negative
what?
f- Negative f.
Yanko, why is that?
Because it is an odd function.
Because what is odd function, Yanko? Because Yanko is odd function?
No, because f of x is an odd function.
Say it clearly, because f of x is odd function. Alex, what would be the second part give you?
I would say plus bracket negative g.
Good, or we can just say negative g directly, it's allowed. And the reason is because we also know that g is odd. Please, the reason you have just spoken right now, I need it in front of it in a bracket. Or if you don't put bracket, just put because. You know, the reciprocal of therefore. Okay? Then say, oh, because f and g are
All functions.
odd functions. Every line has to be explained. Understand? Which is equal to, then you can factorize, isn't it? And in the bracket, what do you have?
Sum of two odd functions.
Oh, come on, higher stories here.
Negative a and negative.
What do you have in the bracket? H. I don't want story. We're not going to write the sum of, are you going to write the sum of THESUM? Come on, stop speaking like that. Does it make sense? So you can see clearly that H of minus x gives us back this. So what's your conclusion? Therefore,
H of x is.
no, you go back to your statement.
Oh, the sum
The
of
sum.
two
The
odd
sum is indeed an odd function.
Sum of two odd functions.
Does that make sense? I'll write the conclusion later. Let me focus on this because of our time. This says G is defined as follows. Find B. If G is odd, clearly, since G is odd, then what happens? Talk to me, anyone.
The x-intercept is 0.
What?
The x-intercept is 0.
Is there anything about
No.
that here?
No.
Since G is odd, what is the first thing that comes to your mind?
G of negative.
Oh, g of negative x goes.
Come on, guy. That's what you should always think of. That's what you should always think of. Okay? So this is the equation you want to solve. G of negative x means when x is negative x from here. And that's negative x plus 1, right?
Yes.
1 over negative x, right? Plus b. And that is going to be negative of everything you're looking at here. Right?
Yes.
Yeah.
So this is what you simplify to get your x. Clearly, you can't just divide because they are not the same.
Yeah.
So you have to open the bracket.
Uh-huh.
If you open the bracket, you have,
X will cancel out.
so you have plus 1,
Yeah.
Yeah.
followed by minus bx,
Minus bx.
followed by
Minus
minus 1 over x,
X.
followed by b. Then here,
X will cancel out again.
then you have again minus.
1.
So after we expand, we're going to put the minus immediately. Okay, I want to skip that step. Is that okay?
Okay.
Yeah.
Then when you expand with this, you get bx.
Yeah.
Then with that minus,
Negative x.
when you expand this, you get 1 over x. With that minus, when you expand, you get your b again. Then you have. So clearly, some things are the same on both sides.
Use 1.
Can you see them?
Yes.
What cancels first?
Negative bx.
Negative
1
bx
over
cancels negative bx. What else?
Negative 1 over x.
Negative
1
Negative
over
1.
1 over x. So our problem is solved, right? We only have one variable now. So we get plus b here, we bring the other one. Minus 1, you take this away. If 2b is equal to minus 2, then your b is negative 1. Piece of cake, isn't it? The last part. Let f of x be an even function, such that these 2 points